6.5 graphs of tangent and cotangent. So we start with the unit circle and look at all your points, your ones and zeros and things. And look at this chart down here. I've already pre-filled it out to save time, so you can pause and fill out if you need to. But we already know that tangent is y over x. So if you look at the different angles here, specifically look at an angle of 0. If you do y over x, you're going to get a value of 0. But if you go to pi over 2 and you do y over x, you get 1 over 0, which is undefined. That's kind of a big deal on a tangent curve to get an undefined, okay? And you might notice down here at 3 pi over 2, it would also be an undefined, okay? So you can fill out those charts, but notice in the chart for tangent and for cotangent both, you're going to have several places where there are undefined values. So thank you, Cooper, for showing my mistake. You guys might have already seen it, but way down here, 1 over 0, of course, would be undefined. So make sure you fix that in your chart. But the main takeaway from this chart is going to be that we're going to see some asymptotes on our graphs, okay? Our asymptotes on our graphs. So let's go to Desmos and just see what this looks like. Here's a graph of a tangent function. Tangent is periodic, and periodic means that it's going to repeat, okay? So you can see that curve. It kind of reminds me of x cubed. It reminds me of that disco function, but it's going to repeat, 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 repeat. And you should be able to tell, I don't know, there's going to be asymptotes, okay? So here's a cotangent. Here's tangent, here's cotangent. What I want you to do is memorize two really key differences between these two, okay? On tangent, I want you to memorize that this thing goes through the origin and it's increasing. Okay, so if you want to write that down, write that down. Tangent goes through the origin and is increasing. Cotangent doesn't go through the origin and is decreasing. If you can memorize those two things, graphing these is really going to be a lot easier. So we go to the tangent function, and basically you should notice that there's going to be an undefined whenever the x term is 0. Because tangent is y over x, so anywhere where the x coordinate is 0, there's going to be an undefined. So namely what that means is at pi over 2, there's going to be an asymptote. And at 3 pi over 2, asymptote. And at 5 pi over 2, or if you go around the circle backwards, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. There's going to be all these asymptotes. Okay, that's kind of your boundary line between those curves. Okay, other than that, if you look at where the y coordinate is 0, there's going to be a 0 at 0 and at pi and at 2 pi as we go around, and at 3 pi, go around backwards. It would equal 0 at each of those values. Okay, now I'm not going to be real specific for this first example, but basically your curves are going to look like this. I kind of imagine, it's not quite the same pattern, but I kind of imagine if I had a parabola and I twisted one of its arms down. That's kind of how I draw it. I know it's not the same relationship, it's not quite the same pattern, but that's what we're looking at. So is this continuous? Well, no. If there's asymptotes, then it can't be continuous. So the x-intercepts are multiples of pi. And the period, okay, here's how you can tell the period from this graph. The period would be the distance between two of the asymptotes. Okay, so this distance right here would be the period. And if you notice, that's four tick marks on my graph paper here. Okay, so what does 4 tick marks on this graph paper represent? Pi. So this period, the period of this graph is pi. Amplitude. Technically, you can't call this an amplitude, okay, because there is no maximum on this graph. It goes up forever. There is going to be an A number that we're going to use, but we can't really call it an amplitude. We'll have to call it something else. Symmetry. Symmetry with respect to the origin. This would be odd, and odd functions have this property. Tangent negative x equals negative tangent x. That means we can pull the negative out. So now let's do the same for a cotangent. So cotangent, we know cotangent is x over y. So if you look at x over y, then there's going to be asymptotes anywhere where y would equal 0. When you get 0 on the bottom, that's going to be bad news. That's going to be asymptotes. So there would be an asymptote at an angle of 0 and an angle of pi. That's what I just highlighted, 0 and pi. And so keep that going. Asymptotes at 2 pi and 3 pi, negative 2 pi. All right. Then there would be a 0. It would equal 0 anywhere the x coordinate is going to equal 0. So at pi over 2 and at 3 pi over 2, 5 pi over 2. Okay. Now remember, I told you to memorize. Cotangent is going to be decreasing. So the graph kind of looks like this. I see 6 full periods of a cotangent graph on the screen. Continuous, nope, it has asymptotes. X-intercepts, we've seen this before, but x-intercepts would be located at odd multiples of pi over 2. I accidentally scooted the amplitude over here, but period is going to be the same thing. The period is that distance between the asymptotes, and the period is pi here. And again, technically, we can't call that an amplitude. There's no maximum. This has symmetry with respect to the origin, just like the other, making it odd and giving it this property. Cotangent negative x equals negative cotangent x. Steps for graphing tangent and cotangent, they're going to look very similar to what we've done before. Step 1, we're going to ignore the shifting. We want to find the period, and you got to be careful here because it's different than the formula we've used before. It's just pi over b. Last time it was 2 pi over b. This is just pi over b for tangent and cotangent. And I'm not calling it the amplitude, I'm calling it the stretch. That a number is going to be important to save us some time. Step 2, determine whether the graph starts at 0 or straddles 0. All right. I told you to memorize a couple of things. We want to know that tangent straddles 0 or hits the origin and is increasing. Cotangent starts at 0 and is decreasing. If you've got that memorized, these problems are going to go pretty quickly and you won't have to do a whole lot of calculation. Step 3, use the circle to evaluate. Step 4, shift as necessary. Step 5, join points with a curve. All right, so most of it's pretty similar to what we've done in the past. Let's look at example 1. Okay, example 1 is a tangent. So I think the best thing that you can do is understand that it's going to look like that before you even start. Okay, now that's not very accurate because I don't know how tall it is or how wide it is. But if you've got that thing memorized where you know a tangent function is going to be centered at the origin and it's going to be increasing, then you've got a huge advantage and a huge head start. Okay, so you want to look for the amplitude number, or the A number is 1. call it the stretch if you want. And then the period is going to be calculated as pi over b. But that's this 2 right there, pi over 2. So the period of this graph is going to be pi over 2. Okay? Now, people mess up on this, but on my graph paper, pi over 2 is worth 2 tick marks. Don't draw that in there. Okay? Do you guys understand? You can see that? Pi over 2 is worth 2 tick marks. So if you've got memorized that a tangent is straddling the origin, then what you'd have to do is kind of back that up so that your 2 tick marks are going to be 1 on the left and 1 on the right. All right, it's got to be half and half, half on this side, half on that side. So when you draw your asymptotes, half of that pi over 2 is going to be on the left and half of it's on the right of the origin. Okay? Remember, 2 tick marks represents pi over 2 on this graph paper. Different graph paper might look different. It might be wider or something, but this graph paper, 2 tick marks, pi over 2. All right, now think about what we always do. Take the period and cut it in half, and cut it in half again. All right, so put those little bitty tick marks in there. I know it's small, but put those little bitty tick marks in there, just like what we've been doing with sines and cosines. Okay? Now, essentially we're plugging numbers in without having to plug them in. Okay? So if you look at this tick mark right here, all right? Don't draw that arrow. But that represents pi over 8. Okay, because we know this is pi over 2, and so half that must be pi over 4, and half that must be pi over 8. Really what we're doing here is we're plugging in pi over 8 into this function. Thing is, if you plug in pi over 8 right there, times the 2 is going to take you to pi over 4. We would really be calculating tangent of pi over 4, and tangent of pi over 4 equals 1. So there's going to be a dot right there, even with that pi over 8 tick mark, and equal to 1. Now, it just so happens that that 1 is the same value as that a number. And so knowing this is going to save us a lot of time. If we plug in 0, that's right here. If we plug that in to our function, you would end up finding tangent 0, and tangent 0 is equal to 0. And then if we look right here, that's negative pi over 8. If you plug in negative pi over 8, it's going to turn into negative pi over 4. And tangent of negative pi over 4 is negative 1. You're going to have a dot right there. So get those 3 purple dots down right there. Okay. Now, I've talked a lot more than I would need to, because all you really have to do is think about this a number is 1. And I know it's going to be increasing and go through 0. Once you know that, you don't really have to do a whole lot of thinking or calculations. Draw your curve through. That's 1 full period of the tangent curve. Does anybody know how many full periods I could fit on this graph paper right here? 12, that's right. I'm not going to draw 12 just to save time. Let's just draw one more though. So 1 full period is 2 tick marks. That's pi over 2. You'd cut it in half and half again. You'd put those dots at negative 1, 0, and positive 1. And draw your curve through. Now I've got 2 full periods. I could fit 10 more, but I'll leave that to you. Let's move on to this one. Okay. So you can call the a number negative 3 if you want, or you can call it 3 with a flip if you want. Thinking about it as a flip is useful because this is a tangent curve, and normally a tangent curve is going to look like that. It's going to go through 0 and it's going to be increasing, but this one has a flip, so I know this one's going to be decreasing. Okay, it was increasing. Oops. It's a flip. Now I know it's decreasing. So keep that in mind. The period for this one Remember, period is pi over b. So we have pi over 1/2. You'd have to multiply by the reciprocal, and you're going to get 2 pi. So the period for this one is 2 pi. And honestly, guys, the bigger the period, the easier on you it's going to be. Okay? It's kind of nice that there's only, well, can you tell me how many are going to fit on this graph paper? There are going to be 3, right? There's a total of 6 pi represented on this graph paper. And so if you take 6 pi divided by 2 pi, you're going to have 3 full periods that fit. Okay? But think about it. We've memorized that tangent goes through the origin, or it's centered at the origin. So if you think about it, a period of 2 pi is how many tick marks? 8, right? 8. So if we're centered at the origin, that means half of them have to be on the left and half of them have to be on the right. Okay? So I don't want to draw that in there, but I want to make sure you understand that. We'd have to go over to negative pi and positive pi in order to make that period of 2 pi and this function be able to straddle the origin. Okay? So think about what we do. Cut that period in half and half again. Those green marks there are important because that's how we know where the dots go. So here's what you do. We've memorized that this thing is going to be decreasing because of the flip. Okay? But we also have this number of 3. So I don't need to plug in those numbers because I know the pattern. Right? You can plug in the numbers if you want. You're plugging in 1 green tick mark is pi over 2, 1 green tick mark is 0, 1 green tick mark is negative pi over 2. Feel free to plug all those into this formula and see what you get. Okay? But I know the pattern. Because this is going to be decreasing, I just take my dots and I go, okay, 3, 0, negative 3. That's going to make this decreasing. Okay? So line up your numbers with those green tick marks. And just make sure that you've got a decreasing curve. Draw the curve in. Okay, so let's go ahead and fill in the other 2. You would have dots at 3, 0, negative 3. And 3, 0, negative 3. Watch your spacing. Okay. One way that people will mess up is if they put the dots like here, here, and here. That wouldn't be right. They have to be equally spaced, okay, and equally spaced from the asymptotes. Number 3, we're graphing a cotangent graph, and I want you to have memorized when you do a cotangent, it starts at 0 and it's decreasing. So it's going to look something like that. Okay, it doesn't center at the origin like tangent. It's different. It's decreasing. It's, starts at 0, not centered at 0. So do the other things that we need to do. Find the, well, I can't call it an amplitude, but that a number is 1/2, and then the period is going to be pi over b, but b is 2, so that's pi over 2. Okay, so if the period is pi over 2, and if this thing starts at 0, you're going to have an asymptote at 0 and pi over 2. Let's try that again. Pi over 2 is worth 2 tick marks on this graph paper. Okay, so that's where we would have our second asymptote. Now remember what we do. Cut that period in half and half again. So we're at little half tick marks there. So really, I'm not gonna plug the numbers in. I could plug the numbers in. You're plugging in that first green tick mark is pi over 8, and then the second one is pi over 4, and then the third one is 3 pi over 8. I could plug those into my equation and calculate it in the usual way, but I don't really have to because I've memorized what this thing looks like. Okay, when you plug in the first tick mark, you're going to end up getting a half. Second tick mark is 0. Third tick mark, negative 1/2. Nope. Try your best to draw a smooth curve through, and that's the first period. Now we're going to have to do 11 more of those. Let's just do one and move on. Or let's do one more, I mean. Period of pi over 2. Cut that in half and half again. Going to go 1/2, 0, negative 1/2. The only reason I know those dots is because I know that it's decreasing. Curve to the top, curve to the bottom. That's 2 full periods, and I'm just going to assume you know how to finish this thing up. Let's move on. The next one is the first one that has a shift. So that plus 2 right there means that we're going to end up shifting this thing up 2. Okay, it's a tangent curve that's shifted up 2. So we kind of just ignore the shifting. And look at the function without shifting. It'd be y equals tangent x. We can see that a number is 1. And we can see the period is pi over 1 or pi. Now for a tangent, I told you to memorize. This thing is going to be increasing and centered at 0. So we pretty much know what that thing looks like. If the period is pi is 4 tick marks, right? This is something that a lot of people will miss. Okay, you got to be really careful on this one. This is the only one. Tangent's the weird one. Tangent is centered around the origin, so 4 tick marks, or pi, is actually going to be pi over 2 on one side and pi over 2 on the other side. Your 4 tick marks have to be on the left and the right. Now, I could draw the asymptotes, but when there's shifting involved, you're going to end up sometimes having to shift the asymptotes too. So you might want to hold off on that. So what might be a good idea is if you do this, let's just call our asymptotes x's or something. We're going to have an asymptote there and there before the shifting, of course. This is a tangent graph, okay? Tangent graph is increasing, and that amplitude number is 1. So all I do, all right, if you cut that in half and half again, right? Okay, all I do is I'm going to go, remember that a is 1. I'm going to go negative 1, 0, and positive 1 so that I can make my curve increasing. Okay? Now, I'm not going to draw this curve because I know it's shifted. So I guess you could call those x's right there, right? But I need to shift everything up 2. So let's go ahead and do that. Let's shift everything up 2. Up 2. Up 2. Up 2. And your asymptotes shifted up 2 as well, I guess. But that's just going to, I mean, that's not really going to do anything to your vertical lines, your vertical asymptotes. You've still got the same vertical asymptotes there, even if they're shifted up. So then let's draw that curve through. And we have our tangent curve that's been shifted up 2. That's 1 period anyway. Let's go ahead and draw another one. Remember the period was pi, and that's 4 tick marks. So really, once you get the first one, you can just copy over the dots and draw another curve. You can do that as many times as you need to fill in the graph. Okay. Number 5, we've got a cotangent, and you should notice a couple of shifts. This -2 means we're going to shift the whole thing down 2, and then this minus pi over 4 means we're going to shift to the right pi over 4. So I would recommend you just kind of ignore the shifting. We'll put it back in later. If you took out the shifting, we would just have negative cotangent x. And you should have that memorized, what that looks like. Okay? Negative cotangent x. Well, cotangent x normally is decreasing, but you're going to have a flip. And so if you have a flip, it's going to be increasing now. Okay, we've got an increasing graph that starts at 0 as opposed to being centered on 0 like tangent. We can find that A number. A is -1, okay? That negative is what's going to make it flipped. And then your period is going to be pi over b. In this case, b is 1, so pi over 1, you're going to get pi. Okay? So we have a period of pi. How many tick marks is that? 4, right? Okay. So we would know we're going to have asymptotes starting at 0 and pi. Now, I'm not going to draw my asymptotes yet because I know I'm going to end up having to shift them anyway. So let's just, instead of having to draw 2 sets of asymptotes, I'll just wait and I'll draw my asymptotes later. So I'm only looking at the unshifted, okay? The unshifted curve, this -1 is what gives everything away, okay? I know this thing's going to be increasing, so I'm going to go -1, 0, and 1. I use this number, -1, and force my graph to be increasing. You can plug numbers in and make a table if you want to, but this shortcut's pretty cool, I think. All right, so that would make the unshifted curve. All I need to do is now shift everything. So down 2 and right pi over 4. Pi over 4 is like 1 tick mark. So when I say down 2 and right pi over 4, I'm really going right 1. So take your asymptotes, and we're going to go down 2 and right pi over 4, down 2 and right pi over 4. Those are your asymptotes. And then your green dots are going to go down 2 and right pi over 4, down 2 right pi over 4, and here. So I'm going to go ahead and draw those asymptotes through here. Those are the shifted asymptotes. And here's my flipped cotangent curve. I've got a flipped cotangent curve with period pi that's been shifted down 2 and right pi over 4. All right, so last thing, we would just fill in the rest of those periods. So just copy the dots over. Make new curves. Notice what happens if you run out of room. If you run out of room, you run out of room, you're done, okay? Just stop and don't worry about it. Sometimes people try to squeeze in an extra little piece of a curve when they don't have enough room. So go over 4 marks, that's pi. And make another curve. Got room enough for another little piece of a curve. Doesn't have to look perfect, but do your best. It should look pretty good. Cool.